This conference will now be recorded.
Yeah, in today's session, we're going to discuss about Pandas data frame. In Pandas data frame, how to manipulate the data. We're going to see how to add the column in the Pandas data frame, as well as how to drop the missing values. Okay. In today's session, we're going to see in the data manipulation, Pandas data manipulation. We're going to see about the how to handle the missing values. How to handle the missing values. Okay, if you talk about missing values, or if it is a customer data, the customer data, some of the customers they won't share the salary information. Some customers they won't share the address information. Okay, because it's a very sensitive information. Some of customers might not be sharing this in the confidential information to the any third party vendors. At the time, this missing value concept will occur because some of the fields, address field will be missing. Some of the fields, like if you take phone number field will be missing, and salary field will be missing because it's going to sensitive information. Because of that, some of the rows records, some of the records, we can be able to see the missing values. If you are doing some data analytics, first thing you have to handle those missing values. There are n number of ways there to handle the missing values. Someone will take the mean of the remaining values and they will take average of all the values and then put in the missing value field. For example, I have 10, 20, 30 and 40 data is missing. 50 is there. I'll take average for all the four numbers and then I'll get the average and then I'll place it in the missing value field. This is how they will handle in the data analytics. There are different approaches are available. Not only mean, sometimes they'll take median, okay, and then how many frequent values are available. Based on the frequent values, they'll put in the missing value field. There are n number of options are available. They take mean, median, or mode, means how many values are repeated. That values will be placed in the missing value field. Okay, because of some sensitive information, customers never share those informations to the any third party vendors. That's what the missing value concept occur. It's very important to handle these missing values whenever doing some analytics, data analytics. Okay, now first thing I'm going to do, I'm going to import my pandas library as pd, and then data frame equal to pd dot I'm going to read csv file. Any kind of flat files you can use read csv api, and then you can able to create a data frame in any kind of flat files. Okay, you can use r and then for escape sequences, and then let's go to ml, and then you can able to see take the path of this directory and place it here, and then put the nba.csv. Okay, and then I'll just display first five records. We can able to see all the columns. Now first thing we're going to see how to handle those missing values. There are three ways are there. Okay, first thing is I'm going to show the API. It's called isNull. We have one API is called isNull. Whichever columns having null values. Null values means NaN. Okay, not a value. If you might have a question. NaN, what's the type? If it says the 7730, it's going to be some int type. Okay, what is NaN type? It's going to be a floating point value. It's going to be a floating point value because NaN has nothing but not a value, not an integer, okay, not an integer. Its type is floating point value. Okay, now whichever column is having not a value, okay, if you apply isNull function, it's going to give true. Whichever NaN appears, it's going to give true. The remaining values will be false. Okay, if you can apply isNull, you can able to see in the salary column, third row, last column, you can able to see true. Okay, if you want to filter which are the columns is whichever the columns are having NaN values, you can use isNull function. external function is going to give the only boolean values. Whichever not a value is available, it's going to give true. The remaining value is going to give false. Okay, this is going to be a is null function. This is how you can able to filter. You can able to filter the not a values. Okay, now you might have a question. It's going to give all the boolean values, but I want to filter whichever record is having NaN, whichever record is having NaN, I want that records alone. At the time, what you can do, you can create a Pandas series. First, you can get a Pandas series. How to get a Pandas series? You can keep some name like bool series. Okay, because it's going to give a boolean value. That's why I given bool series, and then I'm going to keep like PD Pandas is null. Okay, is null. In that you can able to first filter the columns. But what I going to do, I going to take the college column. In college column you can able to see fifth record. Fifth record means cut is 0. Fifth record is not a value is there. What I going to do, I going to apply df of the column name is college. If I apply external function to df college, what will happen? It's going to give only boolean value. If you apply to any one dimension data frame, that is going to be a Pandas series. If it is more than one column, it will be data frame. Okay, but it's a one dimension data frame, it will take the Pandas series. Now, if you run the script and then call this boolean series variable, it's going to give the boolean values. You can able to see. Okay, my fourth row is having the true because the NaN value is present over here. Now it's going to print like this. But my requirement is I want to select the set of records which is having NaN value. Which is having NaN value. At the time, what you can do, you can df, you can pass a boolean index. And pass the boolean index. This bool series, what value contains? Only true or false. For any data frame, you can pass the what you can pass. You can pass boolean index. Now I'm going to provide this df of bool series. Now you can able to see whichever record is having NaN, that record is filtered. Totally 85 rows and then 9 columns. If you multiply 85 into 9, you will get a size. Now what is size? Can you say what is size? Size means rows into columns. We'll get the entire dimensions. 85 into 9. What's the value? 1 minute. I hope you join. Now this boolean series is going to give some boolean values. Okay. For any data frame, you can pass boolean index. For this data frame df, I'm passing the boolean index true and false, and then based on this boolean index, it's filtering only the whichever records are having NaN value. You able to see, right? Which record is having NaN value, it's going to filter all the records. Totally, I have 85 NaN records and 9 columns. Can you say the size for this data frame? 85 into 9, multiply 85 into 9, what size? 85 into 9. Can you say size? I'm asking you, 1 minute. Hope you're not.
This conference will now be recorded.
For this data frame, you can pass the boolean index. Now my requirement is I want to select the set of records which is having NaN values. You can able to see it's filtered, right? Yeah. Whichever records are having NaN value. Now having 85 rows having NaN values and then 9 columns. I want to get the size of this data frame which is having NaN values. Can you multiply 85 into 9? That will be size for you. Okay, that will be the size for you. If you take df.size, it will give the entire data frame size. You can see 4122. You might have a question. What is 4122? If you multiply rows into columns, you will get the size. I am not saying about this size. This is NaN value size. I am saying for data frame size, actual data frame. For example, data frame size. Okay, 1 minute. Data frame size is giving like 4122 because I'm multiplying rows and columns, so I'm giving size. Okay, let it be. This is how you can able to filter the rows which is having NaN. Now next thing, NaN is not a value. Okay, now next thing I'm going to provide how to filter the not null values. Not null means apart from NaN, which are the values is apart from the NaN, the remaining values are not null values. You can directly apply BF is BF not null. Sorry, instead of is null, you can provide not null. Can you app if you sorry not null. Now it's going to give again the boolean value because is null and sorry. Okay, 1 minute. Is null and then not null. It's going to give only the boolean values. Now you can able to see the college column. Fifth row, NaN values present. It's giving false. The remaining values are true. Now, can you say I want to filter the records which is not having NaN values? How you will do? I want to filter the records which is not having NaN values. Apart from NaN, I want to select all the rows. How you will select? The previous thing I did, right? The same thing you have to apply here. What you have to apply? First, take some variable. I'm going to take bool series, somewhat variable name equal to pandas not null, and then data frame. I'm going to select the college data column COLLEG. Sorry, COLLEG. Now I'm creating one time data frame that is going to panda series. Okay. Now I'm going to pass the bool index because this bool series is going to give the bool index for a particular column. You can able to see bool series is going to give the only boolean values. I can pass this. This is the index to my data frame. I'm going to provide PF of bool series. Now it's going to give only whichever record is not having NaN. It's going to give all the values. Don't look at this salary column because I'm filtering based on
college.
I'm filtering college column. That's what you have to see because in college column I'm not able to see anything. It's after zero index, first index coming again, third row, fourth index we having some null values. It's skipped, right? It's skipped up, and then fifth also skipped. Fifth also having the NaN values, and then it's coming to 6 like this. You can able to see all the things. Okay. Okay, now fine. Now this is how you can able to filter the null values and then not null values. Okay. Totally how many, what size of this? So the data frame. Size of data frame. You want to multiply it. You can say size. If it can, the size means dimensions. 373 into 9. Okay. And then if you multiply, you will get some value that will size for you. And then data frame is having 373 rows and 9 columns. 373 rows having not null values. Okay, fine. Now we're going for a third approach. Fill the missing values. I want to fill the missing values. Whichever data frame having missing values, I want to fill it. Okay, fill the missing values. Fill the missing values. Okay, df dot head just to display 10 records for this up to now. You can able to see like in college column you can have NaN values in the 5th row as well as 6th row. You can see consider 0. No, fourth row. It's going to be a 5th row.
5 and
consider 0. 5th row and then 6th row we having NaN values. I want to fill the values instead of NaN. I want to fill the values. And the Spark we have used fill NA, right? The same thing you can apply here in the Pandas data frame. First, what you have to do, df dot, that's one AP will be there, fill NA, whichever not a value is available, you are going to fill the values. Okay, now in this various attributes are available, just use a tab, shift tab, you can able to see methods. Okay, first one is methods and then axis. Okay, you're going to axis means you're going to apply for row or column. 0 means row, 1 means column. First thing,
Column.
I'm going to apply the method. What method is, you might be asking. Okay, it's called ffill. Ffill means forward fill. Forward fill means the Georgia state is there, right? Before NaN, what value is there? Georgia state. The Georgia state will be applied here. That is called forward fill. If I use B fill, what value will be placed here? Called backward fill. Backward fill means LSE value will be placed here. This LSE value again will be placed here. That is called backfill. Okay, now I'm going to use forward fill. Forward fill means Georgia state will be applied in the NaN. Instead of NaN, Georgia state will be applied. After applying here, this value will be Georgia state will be applied again to this field. Okay, now method equal to forward fill, and then you can use axis. Okay, you can use axis equal to 0, and then I'm not going to do anything. Okay, if you want to change the data frame, what do you have to provide? In place equal to true. If you want to do anything in the data frame, you can use in place equal to true. As of now, it's not required for me. I'm going to show to you head of 10. Now you can see, compare this data frame with this data frame. Instead, after Georgia state, we have NaN, right? We have NaN. What happened? I'm using the forward fill. This previous value copied into the NaN field. Now we can able to see there are two Georgia states available. Are you there? I hope you understood.
Yeah.
Yeah. Now I'm going to apply the B fill. What will happen? What value is going to come there? I'm going to apply the B fill. These two values are NA fields. If I apply B fill, what value is substituted? B fill means backward fill. Backward fill. What value substituted? You can see here, like 1 minute. Yeah, you can see it's a backward fill. Backward fill means LSE value will be copied here. Again, LSE will be copied here. It's a backward fill. Backward, whichever values having not having NaN values, that value will be copied into the NaN field. Okay. Now I'm going to apply the B fill. You can able to see this LSE is copied here. The past, current value is copied into the remaining NaN fields. LSU, and then LSU. That is called forward fill and backward fill. There are n number of options available. Okay, like you can use backfill as well. Instead of B fill, you can expand it backfill. Same thing will happen. Right? All backfill or B fill or F fill or forward fill. Anything you can do F fill or B fill or backward fill. Okay, fine. I hope you understood. Now, what I'm going to do, I need only 20 to 30 records from index. 20 to 30. Better you go for slicing, right? You go for slicing.
That's
Now,
nice.
yeah, you will get like from 20 to 29. Okay, because you're taking 20, 10 records are there. 20, if you take consider 20, it will be 10 records. Now, okay. What I'm going to do? I'm going to take salary column. I'm going to take salary column. Okay, I'm going to take salary column. Yeah, I will take a college column itself. In that college column, I'm going to place some value. What you will do? First, you have to pass the index column label. You have to pass. Sorry, not index column label. You have to pass college, and then you have to use one API call fill NA. Fill NA you can apply, and then fill NA, that is fill NA, and then If you don't know the attributes, you can use Shift Tab. It will suggest you the attributes for you. In that, I'm going to provide the value. First one is value I have to provide. Okay, now I'm going to provide something like okay, mm, what I can do, I'm going to change whichever value NA is present. I'm going to replace the value instead of NAN. I'm going to change the values no college name, no college name, and then I'm going to use axis equal to 0, axis equal to 0, and then in place equal to true. Okay, now what will happen is going to affect your data frame because you are using in place equal to true. Okay, it's going to change your data frame itself. Now if we use the df, you can able to see in the fourth record, you can see no college name is present. Instead of NAN, whichever value is having NAN, I'm going to fill the value as no college name. Okay, fine. This is how you can use in place equal to true. In place equal to true. Now totally we are having around 458 rows and 9 columns. This is going to be the original size of the data frame. If we multiply, we get the size of this data frame. Okay. Now, okay, using fill NA or replacing. There is one more API to replace a value, whichever value is having NaN. Okay. Sometimes interview they will ask question. Without using fill NA, can you replace the values? Without using fill NA, can you replace the values? Okay, you have to say that's one API called replace API. Using replace API, I can able to replace the values. Now we're going to replace. You can see here replace df dot replace, and then if you don't know the attribute, just use shift tab. In that, first attribute is going to be to replace. To replace, I'm going to take the attribute to replace equal to whichever value is having NaN, I'm going to replace a value. For that, what you're going to do, if you want to define NaN, you can use numpy library. Import numpy as np. Okay, now take this np. Using numpy, you can able to define the NaN value. That's what I'm saying here. Using numpy, you can able to define the NaN value. Yeah, I defined. If I hang some NaN value, I can replace to value. Value attribute is there. I'm going to make minus 999. Whichever value is present, I'm going to make it as minus 999 using replace API. I'm using some numpy library because I want to define NaN. That's why I'm using np.nan and value equal to 999. And then if you want to set some axis, you can set the axis. And then in place equal to true means it's going to affect the data frame. Okay, as of now I'm not going to do anything. I'm going to use directly head of 10. Now you can able to see whichever value is having NaN. You can able to see minus 999.0 minus 999.0. Okay, because I am not giving any string value here. I am giving only integer value. Okay, I am giving only integer value. But previously I changed to no college name because here NA value will not be available here. NA value will not be available here. Okay, that's what it's not replacing here. Okay, now 1 minute. Yeah, here you can see it is replaced as minus 999. Apart from this, it's replaced anywhere. Apart from this, it replaced anywhere. Let's have 20 records. Let's see whether 999 is present anywhere. 999 hyphen 999. Okay, I have 50 records. Let's see whether any 999 is present. 999. Okay. Okay, let it be. I'm not able to see any record, but I can able to see in this field minus 999.0. Okay, because in the salary column NA is value percent. So I'm replacing the values minus 999. You can change any value. Okay, you can change for 888. You can able to see 8999 is changed. Okay, this is how you can able to uh, replace the values which are values having the NAN. Now, last thing I'm going to say about the interpolation. Okay, using interpolation you can able to fill the values. Using interpolation you can able to fill the missing values percent. Okay, you can able to fill the missing values. Now you might have a question, how these values are filled using interpolation. Okay, I'm going to explain now. Now, first, what you have to do, you have to take the data frame and then you can use interpolate. In the interpolate, I'm going to view my attributes. First one is method. Okay, they given method attribute. In the method attribute, I want to define linear. You might have a question, what is linear? Okay, what I'm going to do, I'm going to have a MS Paint. Okay, MS Paint. Okay, now what are going to happen? Okay, 1 minute. Yeah. Okay, what are going to happen? I'm going to take one x-axis and y-axis. Okay, this y-axis and this is going to x-axis, and then I'm going to find the linear relationship between the salary column. Okay, what happens? Based on this, I'm going to find the linear relationship. Okay, if I plot x and y values, the value should be linear. Okay, if I'm plotting this linear graph, if some of the values are missing in the middle, what will happen? It will take the middle values. For example, have one number 10, 20, 30, 40, 50, 60 is missing, 70 is there. 70 is there. Okay, now I want using linear graph, I'll plot this values and then this whichever values is missed, that values find from the linear graph, and then you can able to fill where NA field is available, not a values field is available. That's why they use interpolation. Interpolation, what will happen? You can able to fill the values which are filled having NA. Okay, based on this linear graph relationship, whichever values you have, you're going to plot the graph. Whichever value is not available, from this graph, you're going to find the value. From this graph, for example, here I don't have any value, right? I'm going to find from this graph and then I'm going to place in the NA field. Okay, this is how it works. Okay, it works on the linear regression algorithm. Based on the linear regression algorithm, they are filling the values whichever the NA is present. Okay, now they ask you some direction. In that, limit direction will be there. Okay, limit direction. From forward, you're going to plot the graph. From forward, you're going to, for example, from forward, you're going to see. 1 minute, I will take the paint. Yeah, from forward, you're going to see, or from backward, you're going to see. Okay, that's what limit direction. In limit direction, I'm going to give forward. Okay, now I'm going to run the script. You can able to see this third record salary column is having a missing value. Okay, now in salary column you got some values, right? You got some values based on the linear regression algorithm. They are plotting the graph. Based on the graph, what are the values they are getting? They are plotting it here. This is how you can able to fill the values using three methods. One, you can use a replace, or you can use fill NA, or you can use interpolate to fill the missing values. This is how it works. And then you go, if you want to see from the back, you can change the direction. Okay, value is going to 3972723778, right? 39723778. Forward, yeah, same only. This is how you can able to fill the values. Totally contains 458 rows and 9 columns. Now, next thing we're going to see drop NA, but interpolation mostly we won't use. Okay, the machine learning engineers will use this interpolation. There are various kind of interpolation we have. We have various kind of interpolation. Based on the interpolation, they will find the missing values. Now, I'm going to show how to drop a value. How to drop a not NA value. What we will use? You want to drop a values? Drop NA. Okay, I will do one thing. Just I will run these two things. From this I will apply. Okay, now we can apply. df dot drop NA. Okay. Now you can able to see the index. Pandas DataFrame internally have the index. Index starts with zeros. See, 0 record is the first record is there. Second record is not there because in that row NA value is present. Fifth row is not available. Okay, and then we can able to see some few set of rows. Few set of rows are dropped because here is drop in. It's going to drop the entire rows. Fine. Now, 1 minute. I'm going to show various attributes. df dot drop NA. In that, I'm going to use how. I'm going to show how. How is the attribute? I'm going to pass all. You might have a question, what is all? Okay. If the entire row contains NA value, then only it will drop the rows. I'm saying, just take on this row. The row contains entirely NA, then only it will drop. That is called how equal to all. How equal to all. Okay. You can able to see again 1 minute. You can able to see, don't see these things. 1 minute. Drop in it after dropping totally contains 458 rows. It has right. Previously contained 458 rows. Only one row is dropped because I already said to you how equal to all means if take a particular row, all the all the columns should have the NA values. Then only it will drop. Otherwise, if you have some doubts, you can run these things, two more things again. Now you can find the, yeah, now you can find df dot size, okay, 4122. Okay, just can you divide this by 9? Can you divide this thing by 9? 1 minute. 412 divided by 9 divided by 9. 458 rows. 458 rows. Okay.
Yes.
Now 458 rows. Now what I'm going to do? I'm going to apply how equal to all. After applying how equal to all, after it's showing how many rows? 457 rows. Totally
57.
one row is deleted because I already said to you how equal to all means in the single row all columns should have the NA values, then only that particular row will be dropped. Okay, fine. Now I'm going to say a few more things in the drop NA, df dot drop NA, df dot drop NA. Okay, and then how equal to, you can use any. What is the any? Take any of the row. In that row, if any of the column having NA values, that particular row will drop. Okay, out of 9 columns, any one of the column having NA values, that particular row will be dropped. Okay, you can say some axis in place equal true. If you want to affect in the data frame, you can use in place equal true. Okay, that's called how equal to any. You find here how many rows we have. How many rows? 364
364 rows.
rows. Okay, and then if you want to affect, if you want to change the data frame, you can use already know axis equal to 1. I will I will discuss this later. Axis equal to 0. Sorry, axis equal to 0. Rows means 0. In place equal to 2. Okay, and then you can see like df. Now my question is to you. I want to drop all the columns using drop in. How will you do? I want to drop all the columns. We can do. We can do. Can use with the ax you can do. Ax equal to column means
0.
row means 0, column means 1.
1.
Okay. Now 1 minute. You have made making some mistakes. Anyway, wait. Drop equal to. I want drop all the columns. Drop in. Okay. Okay. It's a drop only, right? I thought it's a drop. Okay. If we are using drop, if you put ax equal to 1, it will drop all the columns. But I given drop NA here. Okay. Now what will happen? In that column, if you have any NA values, in the column is the column, if you have any NA values, then it's going to drop the particular column. But totally I have 9 columns. In the 9 columns, I don't have any NA values. Name, team, number, position, age, height, weight, or salary. Here, no NA value is available. It's not dropping. If you want to drop all the columns, you can use drop and then ax equal to 1. It's going to drop all entire columns. Okay, now, yeah, fine. This is how you have to do all these things. Now I want to find the length of my data frame. I want to find the length of my data frame. What API will use? I want to find the data frame. What function? I don't already know, right? Len function. Len of 364. The data frame length is 364 because contains 364 rows. 364 rows. Okay. This is how you can able to handle the missing values. Okay, like you can use is null, not null. Okay, and then for filling the values you can use replace, fill NA, interpolation. Okay, interpolation you can use, and then you can use how to drop the NA values. You can use how equal to all, how equal to any, and then if you want to drop all the columns, if any null value present in the columns, you can use ax equal to 1. If you want to drop all the columns, you can use drop. These are the various APIs you have to use. Now, I'm going to show how to sort a values. Okay, how to sort a values in data frame. How to sort your values in your data frame. What API you have to use for sorting data frame? You have to use sort API, and then you have to sort. You can sort in ascending order and descending order. Okay, you already know it's Python. You can do the data analysis. It's one of the fantastic ecosystem for any kind of data centric packages. Okay, everyone knows Python is going. It's a fantastic ecosystem for data centric Python packages, and then via Pandas you can very easy for importing as well as analyzing data very faster as well. And then you can able to using sort API, you can able to ascending or descending can perform in the Pandas data frame. Now I'm going to show how to sort the values based on rows or based on columns as well. Based on rows and based on columns as well. Okay, first thing what you're going to do one thing. Just run this 2 more lines. Okay, just come here. In that, first I'm going to use DF, data frame, sort values. If you want sort the index, you can use sort index. I'm going to sort only the values because in DataFrame I'm going to have the values, right? I'm going to use sort values. Okay, now before that, using these things just to filter some records, then only you can get the column names. Okay, I have 5 column names. In that particular 5 column names, what you can do, you can apply the sort values. df dot sort underscore values. If you don't know the attributes, just you shift tab. Now you can see the various attributes. You can see the first attribute is going to by. In the by, what you have to pass? You have to pass a label, column label. Okay, row label or column label you can pass. Now in the by statement you're going to pass. What I'm going to do? I'm going to use by equal to in single quotes. I'm going to do sort the value based on weight. Okay, by dot weight to the column and then use shift tab again, and then we can see some set of attributes, and then I'm going to sort the rows. Okay, now axis I want to give 0, axis I want to give 0 equal to 0, and then I'm going to perform the ascending equal to true. If you give false, it's coming in the descending order. If you give false, it will be descending. True means come in the ascending order, and then it's going to affect my data frame. I want to affect my data frame. I want to affect means I want to change my data frame. True, and then okay, and then you have to provide one more option. Okay, sort the values. 1 minute. NA position. Where is your NA position? From that NA position you want to sort. It can be last or first. Okay, what I'm going to do? From first NA can sort the values. For example, here I have salary column. You can able to see I have NAN values, right? After this NAN, it's going to sort your values. That's what is going for NA position. Now, good to go. Just give head of 20. Now you can see the which column you want to see. You want to see the weight column. It has to come in the ascending order, right? It's come in the ascending order. 1 minute. None type object has no attribute. Okay, let it be. Okay, I given in place equal true, right? In place equal true I given. Just hit BF. Now you can see the weight. Now what happened? NA position equal to first. After that it's sorted. You can see, right? 161, 165, and then 169. It's coming in the ascending order. Now we're going to make false. It has to come in. It has to come in. 1 minute. NA equal to NA equal, sorry, NA in place ascending equal to 1 minute. Ascending equal to, yeah, ascending equal to false. So in place equal to true. Ascending equal to false. Now the weight column comes under descending order. 307, 290, 289, 280, 170, 169, 165, 165. Okay, this is how you have to sort the values with ascending or descending order. Now I want to keep the NA portion last. Okay, NA portion last means I'm going to keep the NA last. Now you can't see the NAN values in the topmost. You can see this NAN values in the last row. You can see the weights here. 307, 290. The last row it contains NAN. Okay, this is how you can able to sort the values, as well as you can want to sort the index. You can use sort index API, and then you can able to sort the indexes. Okay, fine. Okay, what are things we can see now? Mm, okay, see, there are a number of things to sort the values. Next session I will discuss these things. Okay, now one simple thing I will do: how to iterate a rows and columns in a Pandas data frame. It's very important actually. How to iterate the rows and columns in Pandas data frame. Okay, now I give one data frame to you. How to iterate rows and columns by using for loop only. Everyone will iterate. Okay, if required, you can able to iterate, but most of the times no need to iterate this Pandas data frame. Okay, now I'm going to use a for loop to iterate the Pandas data frame for if you're iterating this Pandas data frame, you will get index as well as values. Okay, index as well as values. I'm going to keep index comma values. Index comma values in you have data frame df dot iter rows. Iter row means it will iterate the rows one by one, and then you're going to print index comma values into the index as well as values. You can see, right? You can see 405 index, 405 index and 302 index, and then you can see able to see all the rows are iterated. It's going to give two values, index comma values, and then you can see the value as well. Name is name, team, number. These are the values, and 405 is going to be index. Index means 405 row, 405 row. Okay, this is how you can able to iterate the rows in the Pandas data frame. Okay, I'm going to sign off session right now.